Jai Hind viewers, I am Sudhakar Dwivedi, Assistant Professor in Information Technology Department, AKG Ghaziabad. Today we are going to discuss a very important topic that is related to the Java 8 and onwards enhancements. So in today's lectures and in the subsequent series of the lectures, we will discuss about some of the features that is introduced in Java 8 and onwards. So let's discuss one by one. So as we can see, Java 8 new features in our syllabus. It is mentioned at the Java 8 new features, and some of the topics that is like the functional interface, Lambda expressions, method references, stream API, default methods, static methods, what is the base64 encode and decodes, how we can use the for each methods, how we can use the try with resources, what is the annotations, what is the type annotations, repeating annotations. We will discuss about the Java module system in this unit, about the diamond syntax with the inner anonymous classes and diamond operators, what is the local variable type inference, switch expressions, yield keyword, text blocks, records, and sealed classes. All these we have to discuss in this series. So as we can see in this series of the lectures, we can discuss the functional interface, Lambda expressions, method reference, what is the stream API, then default methods, static methods, and base64 encode and decodes, and for each methods. But for today's lecture, we will stick to the functional interface. So what exactly the functional interface is, and why we want to discuss it, and what is the advantage of using the functional interface, today we will discuss. So what is it actually? What is the functional interface? So we know the interface. The interface is a special type of the class that have only the abstract methods. And in this functional interface, if I'm talking about, so the functional interface introduced in Java 8 and allows us to use the Lambda expressions. So first we have to discuss what is the purpose of this functional interface actually. So the functional interface is a special type of the interface that have only one abstract method actually. So in the functional interface in Java is an interface that contains exactly one abstract method, and it may contain any number of the static and default, that means non-abstract methods. So functional interface is an interface that have exactly one abstract method. That's why sometimes it is also known as the SAM, single abstract method interface. So the functional interface actually introduced in Java 8, and as we have, I have said, it allows us to use the Lambda expressions to reduce your code. That means the basic purpose of using the functional interface is to provide the clear and concise code, and it enables to use the Lambda expressions. So by using the Lambda expressions, we are allowed to use the short and concise code. So that is the purpose of the functional interface. So functional interface having exactly one abstract method, and it may contain, as I have mentioned, it may contain some of the default methods or some static method also. But the basic purpose of the functional interface is to reduce the boilerplate code. That means it eliminates the need of the anonymous classes. It needs the classes to implement the particular interface, as we were using to implement the interface earlier. So here we can eliminate all these lengthy implementations through the Lambda expressions or the method references that we will discuss in the subsequent series of the lectures. So in short, we can say the purpose of the functional interface is to just reduce the code, so that we can just write the code in a very clear and concise manner. And yes, it also improves the readability, makes the code simple and easy to understand. It also supports the functional programming where the functions can also pass as an argument. We will discuss about the stream API in the subsequent lectures. And the functional interface helps to implement these stream APIs. That means we can just implement the functions of the stream API, like the filtering, mapping, and the processing the collections. And it also promotes to reuse the logic. That means it provides the code reusability. So It is introduced in Java 8, and as I have mentioned repeatedly, that it enables to use the Lambda expressions. And the Lambda expressions just provide a shorter and more readable way to implement the interface without writing any lengthy anonymous class code. That means we do not need to write an anonymous class. We can just provide the Lambda expression implementation of the functional interface. That helps us to provide a short and a clean code. So functional interface, as it can have only one abstract method, so it is also known as the single abstract method or the SAM interface. So from Java 8 onwards, to represent the instance of the functional interface, Lambda expressions can also be used. So this is the one example we can see here. So this is an interface. This is the interface named my interface here. And we can see here, this has only the single abstract method. This is the abstract method. There is no implementation of this method. So this is the single abstract method here. And this is the default method. We can write the implementation of default method here. So as I have said, the functional interface may have the single abstract method. The abstract method is always be a single. No other abstract method will be here. But it may contain the various default methods or the static methods. So when any interface have the single abstract method and a number of the default and static methods, it may be considered as a single abstract method or the functional interface. As we can see here, we have provided an annotation @ functional interface. So what is the purpose of this annotation? We will discuss it. So the functional interface annotations we have written to just denote that whatever we are interface we are writing is just an functional interface. That means it will only contains a single abstract method. That means if we have written no abstract method in this interface, or we have mentioned more than one abstract method in the interface, then it will generate an error, right? So this annotation just inform the compiler that the interface that we are going to write is or may contain only a single abstract method. So we can see in this example, so there is a method that have no implementation. That means this is the abstract method, and this one is the default method, and this one is the default method and static method also. So the functional interface may contain the abstract method. It may also contains the default method or static method. But abstract method will be only one. It is a single abstract method interface. So we can just implement this by using the Lambda expressions that we will discuss later on. So now we have to provide the implementation of the abstract method that we have mentioned here. So we can provide the implementations here by using the different techniques. So I have said we have just mentioned the functional interface @ functional interface annotation here. What is the meaning to mention here this type of the annotation? So why we are going to mention this annotation here? What is the purpose of mentioning this annotation? So this is @ functional interface annotation is written above the interface declaration. And what is the purpose of this declaration? It to just inform the compiler that this interface that we are going to write will contain only a single abstract method because it's a functional interface. So the @ functional interface annotation is an informative marker. So it is the informative marker introduced in Java 8 to just indicate that the interface is intended to be functional interface. That means we are going to write a functional interface. That means it will contain exactly one abstract method. That means if we are trying to add more than one abstract method, so it will generate an error. It is optional to write the @ functional interface annotation here. But whenever we are mentioning it, the Java compiler ensures that the interface has only one abstract method. Because we have mentioned the @ functional interface annotation, that means we are just informing the compiler that the interface we are going to write will contain only one abstract method. And we are trying to write more than one abstract method, or we have not written any abstract method and we have written the @ functional interface annotation, then it will generate an error. So some of the built-in functional interface in Java that we will discuss, how we can create our own functional interface, how we can implement the own functional interface. We will also discuss in the subsequent series of the lectures. So there are many interfaces that is already inbuilt and we can use it, like runnable interface that we have already discussed in the multi-threading lectures. Multi-threading lectures, we have discussed how we can implement, how we can create the threads by using the runnable interface. So this is the runnable interface and it contains the run method. So runnable interface contains the run method. For creating the threads, for starting the threads, we have to just override these methods. The comparable functional interface, and this interface has the compare to methods. Action listener has one of the method that is known as the action performed. Callable have the call method. So these are the methods that is available to these inbuilt functional interfaces. Like the action listener is the functional interface and it have the action performed method. And if we want to implement it, we need to override all these methods. So what are the types of the functional interfaces in the Java? So if we can see, the functional interfaces in Java can be broadly classified in these 4 categories. So the functional interface may be function, it may be consumer, predicate, or supplier. So Java 8 introduced the 4 main functional interface types under the package java.util.function. These are widely used in the stream APIs, collections, and Lambda based operations. So all these functional interfaces may be used in the stream APIs, may be used in the collections or the Lambda operations. So the functional interface we are going to write, we can implement all the functional interfaces in the collections or by using the Lambda based expressions or in the stream APIs that we will discuss later on. So the types of the functional interfaces that I have mentioned, it may be predicate, it may be function, it may be consumer or supplier. What is mean? So if we see the predicate type of the functional interface, so predicate type of the functional interface accept only one argument. It accepts only one argument and it returns a value. It returns a value that may be either true or false. That means it will returns a Boolean type of the value or rejects. So predicate functions just accept only one argument and returns a value, either it is true or false. Now the function, it accepts one argument and it returns some value. It returns some value. Then consumer, it also accepts one argument and it returns no result. It returns no result. So consumer returns no result. Supplier, it takes no argument. So supplier takes no argument, but it returns some value as a result. So we can just classify all these types of the functional interfaces types. So as we have seen, the predicate just take one argument and as a result, it will return the Boolean type of the value. The function will take one argument, it returns some values. The consumer take one argument, but it returns no result. And supplier takes no argument, but it returns some of the values as a result. So we will explain. It's a Boolean valued function of one argument. So what is the predicate? So predicate is the Boolean valued function of one argument because it will take one argument and then returns the result. And it is commonly used for the filtering operations in the streams, as I have mentioned, where we will use all these types of the functional interfaces. We can use it in the collections, in the stream APIs, or in the Lambda expressions. So where the predicate is used, so predicate is basically used in the filtering operations in the streams. So in the streams where we need to apply some conditions, and we have to filter some values depend on some conditions, depend on some situations. So on that basis, or on that on the basis of that particular condition, we can apply these predicates, and then we can have the results of this type of the Boolean values. So there are also some variations of this functional interface type predicate. So what is the variations? So as I have mentioned, it will take only one argument and will return the Boolean type of values. But the functional variants of these predicate is the int predicate, it may be double predicate, or the long predicates. So these are the some variations of this predicate. So we can see the code here. I have created a predicate here. So as I have mentioned, all these types of the functional interfaces comes in this package java.util.function, and we are going to use the predicate here. So we have just created a main class here, and we have just created a predicate, and we are going to store the integer type of the values. So here we have just passed one parameter. Here we have just passed one parameter, and we are just checking if the value of this passed parameter is greater than 10. So we are just testing if the value of this parameter is greater than 10, then it will return some value. So what type of the value this predicate will return? It will return either true or false. So we have used the test function here. So we have just created the reference of the type predicate, as we can see here. And on this reference, we have just called the test function of the predicate. That means we have passed one parameter. I have mentioned the predicate can take one parameter, and then it will return the value true or false. So we have, for this purpose, we have used the test function. So we have used the test function. We have passed the value 15. 15 is passed to this parameter, and then it will check here. If the passed parameter is greater than 10, if the condition is satisfied, then it will return true. If the passed parameter is not satisfied by this condition mentioned here, that means the passed parameter is not greater than 10 here, so it will return the false. So predicate functions just comparing the values or just filtering the values based on the provided conditions. So for this purpose, where we need to filter the values based on some conditions, we can use the predicate type of the interfaces, functional interfaces. Now, the consumer functional interface. So the consumer interface, as I have mentioned, the consumer interface accepts one argument, it returns no result. So what is the consumer interface? Actually, the consumer interface accepts one, it takes the argument, but it returns no result. So what is the consumer functional interface? So consumer interface accepts one argument, and it is used for performing an action. It just performs an action. It returns no result. It performs an action like the printing or logging type of the actions. So there are also some variants of the consumer functions like the double consumer, int consumer, and long consumer. So these are some variations of the consumer interface. So as I have said, it will take the one argument, but it performs no action. It just doing the printing task or the logging task. So this is the consumer interface. So this is the consumer type of the interface. And as the value is passed, as the parameter is passed, this parameter is just going to display it here. We can see in the code here. So we have a class named user, and we are just focusing on the name of the user. So we are just setting the name to the name parameter of this user. So this is the main class, that is the database example, and I have used the consumer functional interface. This is the save to DB. That means we are going to save this name of the user to the database. So we are just going to save the details of this user to the database, right? So we have used the consumer. We have created a reference. So this is the reference user, and by this reference we are calling the name parameter here. So I have created one of the object here. We can see this is the object. This is the object of the user. This is the object of the user class. This is the class user. So this is the object of the user class. This is the parameter, and this is goes to this parameter user, and then this will be printed by using this user.name. Here we can see we are using the accept function. So what is the task of this accept function? It takes one input and perform an operations and returns nothing. It just perform an operation and it returns nothing. If we can see the signature of this function, it returns nothing. So I have used the accept function here. We have called the accept function to this reference, save to DB, and just we have passed the object of this class. So object of the class, the required class, is passed as a parameter, and then by using the Lambda expressions, this parameter will be printed. So this is the use of the consumer interface. Then come to the function interface. So what is the task of the function interface? So we have seen the predicate are used for applying the conditions, and based on the conditions we are just printing the result, or we are taking the results. The consumer have taken one argument but perform only action. It returns no result. Function. Now function also take one argument and it may return some of the values as a result. So what is the function here? See. So function interface takes one argument and returns a result. It is commonly used for transforming the data. Like we have a passed value as a parameter, and we are transforming this value as the square of these values, as the square of these passing values. So we are just transforming the values from one form to another. And there are several variations of these functional interface. So as I have mentioned, the function interface takes one argument, but there are several variations where the two arguments are input and output are of the same types. In the unary operator we can take, in the binary operator like the by function, but with the same input output type. So these are the variations. By function takes two arguments and returns a result. As in the function interface, it takes only one argument. The by function will take the two arguments and returns a result. Unary operator, input and output are of the same type, then we will use unary operator. Binary operator, it's like a by function, that means it takes two arguments and returns a result, but with the same input output type. So in the binary operator, the input and output types would be same. So here we can see the syntax of this functional interface. So this is the functional interface. So here the two values we are transforming. We are creating the reference of this, and when the value is coming to this, it will just transform it to another form. This is the one example of using the function with a string. It's just converting, it's just transforming the string supply to the uppercase. So here we have just used the main class, and this is the functional interface. We are passing the string, and this string just converted to the uppercase. So whatever the string is passed, we have called to uppercase method on it, so that it will just transform it into the uppercase. So here we have called the apply function, and we have just passed some string to it on the apply function on this reference by using this reference. So in this functional interface, we have created a reference, and on that reference of the functional interface, we have called the apply method of it. And in this apply method, we have passed the parameter string. This string parameter is just passed to the str reference here, and then we have called the to uppercase method, and this to uppercase method just transform this supplied string to the uppercase. Now the supplier function. So supplier function interface is also a type of the function interface that does not take any input. It does not take any input, but it produces the output. So the supplier function interface is not taking any input, but it returns the output. So the different extensions of the supplier function